Hello students, welcome to Form 2 Mathematics lessons. Today we are going to look at Trigonometry 1, and in our first lesson we'll look at Introduction to Trigonometry, and then we shall look a bit of tangents. I'm your teacher, Mr. Wanyoike from Mary Hill Girls High School. Welcome. Dear students, in our previous lesson we discussed Pythagoras theorem, whereby you were given two sides and one side was missing in a right-angled triangle. Now in trigonometry, a side might be missing or an angle might be missing. And particularly where the angle is missing, we always use the trigonometric ratios. We shall discuss them in our next slide. The word trigonometry comes from the Greek word meaning triangle measurement. Trigonometry uses the fact that the side lengths of similar triangles are always in the same ratio, and this will help us to find unknown sides and angles. In the diagram below, we'll learn how to label a right-angled triangle. Now, the first triangle there, painted green, has the angle theta. Angle theta is made by intersection of two lines or two sides, that's the hypotenuse and the adjacent. So the hypotenuse and the adjacent are meeting at angle theta. So the angle that makes, or the line that makes the angle with the hypotenuse is called the adjacent. The word adjacent means next to. In this case, next to angle theta, that is adjacent. The opposite side is a round ledger, does not form part of the angle in question. In this case, it is shown there with the arrow on the far end of the adjacent and the hypotenuse side, and therefore the opposite never form the angle theta. And we can abbreviate the sides as shown in the angle painted blue, where we have theta, then hypotenuse, we can abbreviate it as HYP, adjacent as ADJ, and then opposite as OPP. Sometimes we just use the first letters. That is opposite, we can use O, adjacent, we can use A, and hypotenuse, we can use H. The sine, cosine, and tangent are the three main ratios used in trigonometry. They are often shortened to as sine, cos, and tan. The calculation is simply one side of a right-angled triangle divided by another. Now in the example below, or in the diagram below, or the way we get sine is by getting the hypotenuse and also in consideration with the opposite. Then we say sine of an angle is given by opposite divided by hypotenuse. Sine of an angle is equal to opposite over hypotenuse. Cosine of an angle is given by adjacent over hypotenuse. And in the third diagram, the tangent of an angle is given by opposite divided by adjacent. Let me do it once more. In the first triangle, it's showing us how to get sine, and sine of an angle, the angle that is shaded, is given by opposite over hypotenuse. S equals O over H. In the second triangle, the middle one, we have theta as the angle in question, the one shaded in blue. Then cosine of an angle is given by adjacent over hypotenuse. C equals A over H. In the third triangle, tangent of an angle is given by opposite over adjacent. T equals O over A. And that's how we get the acronym SOHCAHTOA. toa. Toa. Toa is a very useful acronym because it helps us to find out any missing side, as we said earlier, or any missing angle if we are given some of them. And then the way we use it is as shown in this diagram or in this example, where sine theta is indicated down there. Theta is formed by the side r, which is the hypotenuse, and the adjacent, which is x. And then the opposite of this triangle is y. In this case, sine theta will be equal to opposite over hypotenuse. Our opposite is y, and hypotenuse is r. Cos theta or cosine of angle theta will be given by adjacent, which is x, over hypotenuse, which is r. And tan theta or tangent of angle theta will be given by opposite, which is y, over adjacent, which is x. Class exercise. Label the sides as opposite, hypotenuse, and adjacent. Students, copy the triangles, do the work, and post it in the Google Classroom platform. Let us now look at an example. In the figure below, adjacent length is 4 centimeters and angle x is 36 degrees. Calculate the opposite length. The first thing is to sketch the right-angled triangle in this case, and then you label the information that you have been given. You've been given the angle in question, or our angle theta, and then we also have been given the adjacent as 4 centimeters, and therefore that 6 degrees will be made by the intersection of the hypotenuse and the adjacent side. So the question here is the length of the opposite side, or the side that does not form the angle 36. Now this means that we need to use the formula that uses opposite and adjacent in our SOHCAHTOA. And that formula is the one for tan theta or TOA. TOA, tan equals opposite over adjacent. In this case, our adjacent is 4 centimeters. Opposite is the one that is missing. And definitely we have the angle 36 degrees. For us now to get the answer, or the side O, we need to work out the formula so that our opposite will be given by, now we can say tan 36 is equal to opposite length of adjacent length, which is equal to O over 4. And when we substitute this, we'll find that O is equal to 4 times tan 36. Now students, when we come to looking for this tan 36, we have got two ways of getting tan 36. The tangent of angle 36 can be found in our mathematical tables, in the tables of tangents for angles ranging between 0 and 90 degrees. We'll be looking at that in a short while. And we also have the calculator where we can use to get tan 36. Remember, your calculator must be in degree mode. So you need to change the mode if it's not in degree so that it can give you the accurate trigonometric ratios in question. Now in this case, 4 times tan 36 is giving us 2.9062 centimeters. Students, there are two ways of getting the tangents of an angle. One is by the use of mathematical tables, the 4-figure table, or using the calculator. When using the mathematical table, care should be taken so that you select the correct table Remember, we have several tables of tangents. One could be the table of logarithm of tangents, but we specifically want the one shown on this slide, table of tangents from 0 degrees to 90 degrees. The other way of getting the tangent of an angle is from a scientific calculator. The one, remember, we said that the mode of that calculator, if you are dealing with trigonometric ratios, should be in degree mode. Sometimes students get stuck when it comes to selection of the mode of the calculator. If you want to change the mode, you press the mode button next to the on button where you normally switch on your calculator. If you're using the calculator recommended by NEC, that is FX82MS Casio, if you press that mode button twice, it's going to give you the option of degree, radians, and gradients. So you select one. You select option 1. If you press 1, the calculator will change its mode to degrees. However, remember that if a question requires you to use mathematical tables, don't use calculator to do your workings. Otherwise, your teacher will be able to tell once you use a calculator and the time you have used the tables of tangents or your mathematical table. So read questions carefully. If you're free to find out the ratio of a trigonometric angle, then you can use either. But strictly, if you've been asked to use mathematical table, ensure that you stick to that. Now in this slide, in our example 2, we are going to look for the tangent of 30.7 from the mathematical table. Now, this is how we do it. From the column headed 0 degrees, the one in bold on the far left, where you have 0, 1, 2, 3, 4. So we go down along that column until we get the figure 30. Remember, we want the tangent of angle 30.7. So once we are at 30, we will now move across that line of 30 degrees. We move across until we see the column headed 0.7. On top of it, it has a 42. We'll be discussing that. That one is read as 42 minutes. We'll be discussing that in a short while. And when you move along that line for 30 degrees up to where we have 0.7, then we have a figure there that is 0.5938. So we are using 3 simple steps. 1, in the column headed 0, we move down until we get to 30 degrees. Once we are there, we move across along 30 degrees row till the column headed 0.7 or 42 minutes. Then we read that figure, and that figure, it doesn't have a 0 there, but remember all those figures have got 0 point. Up to 45 degrees, they start with 0 point. After 45, you start with 1 point. So here, the answer is 0.5938. Let us look at another example. Example 4. Given the right-angled triangle below, calculate the size of angle Q correct to 1 decimal point. Now, the triangle we have been given is a right-angled triangle where we have the angle Q, and we've been given the opposite as 4.3 meters, and the adjacent to this angle is 3.8 meters. Then we ask ourselves, from our SOHCAHTOA acronym, which ratio requires to use opposite and adjacent? We realize that that ratio is the tan. Tan of an angle is given by opposite over adjacent. Now the opposite here is 4.3, adjacent is 3.8, and therefore tan Q will be given by opposite divided by adjacent, which is 4.3 divided by 3.8. And once we do that, then we'll be required to find the value of angle Q by looking for the tan inverse. You can see where we have tan raised power -1. That one is not read as tan raised to power negative 1, it is read as tan inverse, meaning we shall go to our mathematical tables and read backwards from the many figures we have been given in the table, inside the columns. Then we read backwards to where we shall find our angle Q. In this case, when you divide 4.3 divided by 3.8 from your calculator, you'll find that it is 1.1315789 and so on. Now we need to get that figure and correct it to 4 decimal points so that we get 1.1316. Reason being, the figures given, they have 4 decimal places in our mathematical tables. Now, using that figure, 1.1316, we go to the many figures we have been given. We look for the one that is very close to 1.1316. And so after 45, we said we have tangent of angles from 1 point something all the way. So the ones where we have very close to 1.1 is the down the column of the one in bold, where we have 1.1, 47 degrees, we have 1.07, and at 48 we start seeing 1.1. The figure we have is 1.1316. So at 48 we'll move along that row now across, and we ask ourselves which figure is very close to 1.1316, and that figure is 1.1303. Remember, there's another one that is a bit far, though close to 8, and that one is 1.1343. Now this figure, 1.1343, is farther from the one we have of 1.1316 than 1.1303, and therefore we consider 1.1303 because it is nearer to the figure we have. And then we read backwards. So when we read backwards, first this column is headed where 1.1303 is headed by 0.5, and then we move backwards, we find 48 degrees, and therefore this figure 1.1303 is the tan of angle 48.5. And because the question requires us to round off to 1 decimal point, then we round off our angle 48.5 to 1 decimal point to get 49 degrees, and therefore angle Q is 49 degrees. We can have another example. The question is, find the size of angle Z in the triangle below. Now this time we are given two sides, that is 8 millimeters and 5 millimeters. Angle Z is the angle in question, and it happens that angle Z is formed by the hypotenuse and the side that is 8 millimeters. Now, for us now to know which ratio we are going to use, we ask ourselves, what are we given? We've been given two sides. Which are the sides? The opposite and the adjacent. Therefore, from our SOHCAHTOA, we ask ourselves which ratio uses opposite and adjacent. And therefore, we realize that it is tan. So we have opposite is equal to 5 millimeters and adjacent is equal to 8 millimeters. And our angle is Z. Therefore, tan X is equal to opposite over adjacent, which is 5 over 8, which is 0.625. Now, for us to know the angle whose tan is 0.625, we need to read our mathematical tables backwards, and we write that as tan inverse 0.625. Read as tan inverse 0.625. And when we read backwards, we find that the angle that is giving us tan 0.625 is 32 degrees. Dear students, we have come to the end of our lesson today. And here we have an assignment. Remember, we had a classwork. You also do it and post it in our Google Classroom platform for Form 2 Gamma. And if you're not in that class, then you can always request for a password so that you can also be able to post your work. If you have any question, remember to ask. Be free, and then you can use the addresses given in the next slide. Thank you, and God bless you.